Hello everyone, welcome to today's problem discussion. So today's problem was given in JEE Advanced 2023 paper 2. This problem is a very interesting problem because this problem is about a coin tossing or coin flipping. This is a very interesting problem because it gives some real feeling also to you because you are all familiar with the coin tossing incident. So let's see what is the problem. A thin circular coin of mass 5 gram and radius 4 by 3 centimeter is initially in a horizontal XY plane. The coin is tossed vertically up by applying an impulse of this at a distance 2 by 3 centimeter from the center. The coin spins about its diameter. That means it is flipping like this and moves along the Z direction. It goes up. By the time the coin reaches back to the initial position, it completes n rotations. The value of n. That means in the air or आसमान में ये घूमेगा कितनी बार घूमेगा that we have to find out. The acceleration of gravity we will consider as 10 meter per second square. Okay. So now before solving the problem थोड़ा देख लेते हैं कि coin tossing में क्या physics और mechanics involved रहता है. So suppose this is a body. Its center of mass suppose it is here COM. If you apply a force whose direction will coincide with the center of mass, then this body will only get linear velocity or the linear motion. You can tell linear motion. That means only it will move like this in this direction, velocity or acceleration, whatever it is. As the impulse is also kind of a force, that is the force applied for a very short duration of time, it will only change the momentum of the body. That means only the linear momentum. But suppose this is the center of mass and you are applying an impulse like this, it is at some distance from the center of mass. That means the direction of the force is not coinciding with the center of mass. It will not only have the linear momentum, rather, it will also rotate. Why? Because this is the amount of impulse, suppose we apply, this will generate with respect to the center of mass, it will generate one impulsive torque, and that impulsive torque, what it does, impulsive force, it changes the linear momentum. An impulsive torque, it changes the angular momentum. That means due to the only impulse, it will have linear motion, but due to the impulsive torque, it will additionally have one rotational motion. So the entire motion of this kind of thing will have rotation plus linear motion. That means this kind of body ये घूमते घूमते आगे जाएगा. So same thing applies for this coin also, because when you want to flip a coin, you have to apply this force or this impulse at some distance from the center of mass or the middle point from the coin. You have to rotate this body as well as you have to throw it upward. So it is a combination of linear motion as well as the rotational motion. घूमते घूमते आगे जाना. Okay. So this is the fundamental concept of or the fundamental mechanics involved in the coin tossing that I wanted to discuss. Now let us solve this problem step by step. Okay. Now suppose impulse J is applied here and the coin mass will consider as M. At the end, we'll put all the values and we'll find out the solution. So, as of now, let us assume that mass is M and it will get, initially it is at rest. If we apply impulse J, what it will do? It will change the momentum of the body. What is the initial momentum? 0. What is the final momentum? Suppose it gets some velocity upward, V. That means change of momentum is mv minus 0. Basically, J is equal to becoming mv. Okay. Now, at the same time, as I told that it is having linear motion as well as the rotational motion. So additionally, this impulse, it is applied at some distance, suppose h from the center. So it will create some impulsive torque. So what is the amount of impulsive torque? That means it will create some moment. What is the moment? J into h, that is impulsive torque. That will do change of the angular momentum of the body. What is the angular momentum? Suppose it is going up with velocity v, at the same time it is rotating with omega with respect to the diameter. So let us assume that with respect to the diameter, its moment of inertia is I. So it will change the angular momentum of the coin. So what is the final angular momentum? I omega. It gets omega amount of angular velocity and its moment of inertia is I. Initially it was static. It was not having any motion. So initially 0. So basically JH is becoming I into. That is the equation number. Now, what is the value of omega? JH by I. And what is I with respect to the diameter? If this is the coin, with respect to the center in the z-axis, its moment of inertia is m r square by 2 if r is the radius. Then with respect to the diameter, it will be half of it. So with respect to this diameter, if it is rotating like this, I will be m r square by 4. So here we can directly write that omega equal to j into h m r square by 4. Now we'll try to solve the problem here. Okay. So we have found out omega, that is 4jh by m r square. Now, ये आसमान में कितना टाइम रहेगा? That means it is a problem of projectile motion in the vertical direction. If you throw a body with velocity v from this point, how much time it will be in the air? कितना टाइम आसमान में रहेगा? 2v sin theta by g, the time of flight. But here it is a vertical projectile motion. So the time of flight will be or the time it will stay in the air, it will be 2v by g. Okay. So it is rotating with angular velocity omega for this much amount of time. So how much angle it will cover during the entire motion? Theta equal to, it is omega into t. It is rotating with angular velocity omega for time t. So the angle it will cover is omega into t. We'll just put the values of 4jh by m r square. T will put 2v by g. Now we'll put the value of v here. V is from the first equation, we'll get j by m. We'll just put that 4j into h, 2j by m. G is already there, m r square. So here we're getting 8 j square h by m square r square g. 8 j square h by m square r square g. We'll go to the next page. 8 j square h m square r square into g. That is the angle it will rotate. So how many rotations it will complete? For one rotation, it need to revolve 2 pi angle. So if it is rotating theta angle, then the number of rotation will be theta by 2 pi only. That is the number of rotations it will complete. Square h by 2 pi m square r square g, that is 4 j square h m square r square into g. Now all the value will put from the problem. So j is given root pi by 2 into 10 to the power minus 2, root pi by 2 into 10 to the power minus 2. We'll just put that. That means square means pi by 2 into 10 to the power minus 4. H is the distance the impulse is applied, 2 by 3 centimeter. 2 by 3 into 10 to the power minus 2 by pi. Mass is given as 5 gram. That means 5 into 10 to the power minus 3 square into r. R is given as 4 by 3 centimeter. That is 10 to the power minus 2 square into 10. Now it is only simple calculation. 2 here it will cancel. Pi here it will cancel. 4 into 10 to the power minus 6 by 3. 3 will go to the denominator, then 3 into 25 into 10 to the power minus 6 into 16 by 9 into 10 to the power minus 4 into 10. Here 10 to the minus 6 into 10 to the minus 6 will cancel out, and then 10 go 4000. 3 will sell, so 3 by 25 into 16. So this is just a simple calculation. 25 5 800 16 50 10, so it is 30. The number of rotations we will do in the air, that is 30. So n is equal to 30. That is the answer for this question. The answer is, we'll write it down here, equal to 30. So 30 rotations it will complete before coming to the initial point. I hope you have understood. Thanks for watching.